Hello. It's nice to see people for real. I thought I'd actually turn up. So, so let's see how this goes. I haven't done this for quite a while. I'm going to try and start on time, see if we can help out the organisers a little bit. If you see me running around and checking the time a lot, it's just because it's probably the first time I've done this live, and as ever, just to add a bit of risk, I've changed the pitch slightly. So we'll see how it goes. I'll do the traditional thing, which we always do at these events. Does anybody, who's familiar with graph databases and who isn't? So, familiar with graph databases, sorry, I should have helped there. Yes? Hand up? Yeah, a little bit, no, that's cool. And who is coming more from the business side or is unfamiliar with graph databases, so they're hopefully, I'm going to help you out a bit and help there. Okay, that's great, thank you. So just in case I can give you a chance to leave if I'm not saying something that's interesting for you. What I'm going to cover very quickly is the latest version of what we are developing. So this is slightly forward-looking, although we're already getting a lot of traction from this, particularly in automotive and also in data operations. And you might think it's not obvious what the connection is. Hopefully that will come through. The key for us, and this is a very personal thing, is this idea that we need to get to real time in operations. We need to stop thinking of BI as something that is done once a week for the execs. We need to think of it more as something that we now need to deliver to the business for their critical concerns. And I'll show you some of the things we're developing right now that we're pretty much delivering as we speak to fairly large global customers. So let's see, let's get the clicker working. I won't spend too long talking about me. This deck should be available. This just basically says I'm old, but the key ones here are really more about the domains I've worked in. I've worked in investment banking, Toyota Motor Europe. I started the enterprise architecture function for them in Brussels quite a long time ago. But if you ever work for a car company, particularly for Toyota, then you find out that they actually spend their entire time training you on what it means to make cars. And so that was 5 years of pain understanding that. But no, it was good. And it gives you a tremendous insight into what it means, what critical operations actually means in cash terms. Chief architect for Zap, as it was, great name. That was bought by MasterCard. It's now the standard push payment system that's used in American Clearinghouse globally. This is why I care about this so much. I, as a contractor, did environment operations for BP Trading. And again, BP Trading, by far the highest revenue running through the business. I believe it's in the trillions of dollars yearly. So when you're doing environment operations, it's really quite unpleasant and scary because the tools available, we didn't have what I've and our team have developed as far as this is concerned, and 10 years of trying to wrestle big data systems into being able to help here. So that's me. This is our standard description of our company. Gives an idea of some of the people we talk to. But the main thing in terms of what are we, what is TigerGraph? It's a distributed graph database. I will talk a little bit in context of what that actually means and how that is different from a relational database. We're not just a database, we also do very advanced analytics over that. That's graph analytics, but actually any analytics we can help with. The main trick we have there is that we can do analytics over the large-scale distributed database, and we're pretty much almost unique in the market in being able to do that. And then in database machine learning, so now machine learning and AI obviously is a big deal, and so we felt that we had to integrate very tightly with that. And I might talk a little bit about that. If people have questions about that at the end, I'll happily go into that in a little bit more detail. And you can see that we've got some relatively large customers. JLR, my favorite customer. I don't know whether Andrew's around today, but they were incredibly supportive and have helped us enormously in this. And we've, I think our first use case saved them about 4 million quid in a week. So we're hoping to repeat that trick for as many other car companies as possible. So this is how I think of TieGraph. So in order to do what we did for a car company, we had to deal with 6 months of production data. That is 4.5 billion with a B parts, each one individually tracked all the way from supplier to literally the car in which somebody bought. That's what you can do in principle with a scalable graph database. The biggest graph we have, which actually is not this one, JLR's is somewhat modest. It's only about, I think it's only up to about, we're not even up to a terabyte yet for them. But we have a 30 terabyte graph currently running with analytics running in real time over that. That's for a credit card loan system. We also have a larger system being built for a telephone company. The fasts, so we are big. We are fast for standard queries. Millisecond latency is standard. We show a standard web API, which means that any system can ask questions very, very rapidly. You don't ask questions as a query, we compile the queries. That's how we can go quickly, is by essentially compiling it very tightly to the database. And we are a full database, so our storage is attached. We're not an analytics layer over other databases. That is both a problem in some ways, because it means that you have to import the data, so we do that really quickly as well, gigabytes per second. I think we're up to about 10 to 100 gigabytes a second now, I think, in the latest ones for larger clusters, because we parallelize across the whole cluster. But what it does mean is that we can answer queries really, really quickly. And finally, smart, scalable analytics, and this is the key. We can do analytics over the entire cluster. There's no mess. You don't have to worry about partitioning. You don't have to worry about losing capabilities as soon as you scale out. Any query you can write on one node, it works across the whole cluster. And we can even do full cluster distributed analytics as well if you've got a really gnarly problem that you need to run. So I tend to say we're the first of the 3 out of 3 graph databases. Generally you can get 2 out of the 3 from our friends and competitors. Getting 3 out of 3 is a bit more difficult, and that's why people tend to come to us, is when they're really interested in doing that. As I say, I'm going to do it in context. The operational user story, which is the one that, as I say, very close to my heart. A little personal story. When I worked for JP Morgan, before I started doing their innovation team, I was contracted to do operations for their fixed income floor, which is by far their biggest moneymaker. And that meant that I was 24 hours on call, and about once every 2 weeks I'd get the phone call, as it was called, which is when somebody you've never heard of, who was the VP of something really serious in the bank, would ring up and say, my screen's not working. I've got $1 billion in trades which I need to drop in 5 minutes. Why? Fix it. And why? And it's like being at war. They say it's 98% boredom and 2% terror. It was a bit like that. And what they want to know right now, when you get the phone call, is who's affected. In other words, who even worse is going to phone you later, your customers? How big is the problem? In other words, is this small report actually a symptom of something much, much bigger? Why? What caused the problem? You need to know that in order, if you're going to fix it in any meaningful way. Who do you call straight away? Because the idea is to call all those customers immediately. You don't want to wait for them to call you. You immediately call them and say, look, this isn't going to happen. If you go to your emergency code red procedure right now so that we've got a chance of fixing it. Root cause analysis is the joyous process that you then go for afterwards to try and work out why it went wrong, so you want to prevent it for the future. And the interesting one, everything's always broken. This is the dirty secret of operations, is that the chances are that 10 to 20% of your system at any one time is down, be it for servicing, for upgrades, for maintenance, because it's being installed, or just because it's broken. And that, how much should I do to avoid the problem in the future, is really important. For a car company, system downtime, I said, €1 million a day. That was kind of a nice round number. I then did some, which is about €700 a minute. I then checked the research. It's actually $22,000 a minute, and that's for one car factory, not even all of them, just one, which sounds about right. basically you can never stop. If as soon as you stop, everything goes wrong. And particularly if you stop for more than half an hour, it can take days to bring it back online because you've got to resequence everything. This is not unusual, and this is just how seriously this is taken. I've put the research in there if you want to check my numbers, but that's a very clear idea. Millions of process events a day operating on billions of parts we talked about. This is not uncommon, particularly in data-driven enterprises. External factors cannot be anticipated. You can't. This is stuff that breaks because you didn't expect them to. It has to be reactive. So therefore, this ability to react incredibly quickly is extremely important. Internal issues cannot always be anticipated. The cleaner pulling out the plug is the classic example. But generally, if you're going through transformation, then things are changing continuously. The chances are some percentage of them will cause a problem downstream, and you just don't know what it's going to be. Network model, it isn't a network model. You've got this flow through this large network of individual elements. And because it's interdependent and it's dynamic, this is what brings us into this idea, which I talk about a lot, not so much here, which is this idea of a digital twin. You are actually have to have a real-time model of your network as it is right now, and you need to be able to do all those nice things we talked about on that real-time network as it is right now. Otherwise, you're not actually analyzing the situation as it is. And finally, external stakeholders will want comprehensive information immediately. Information is everything, and what they don't want is a team of 1 million operators to try and make this work. Networks look a bit like this. A graph database specifically models this kind of thing directly. What does that mean? You have nodes or vertices, which are the elements which you would, in a relational world, you would think of as tables. And then you have the links between them, which in a graph database are explicit things. In a relational database, you have foreign keys, and you use those to essentially talk about links. In a graph database, they are just pointers. And that one difference is what makes these more efficient and more direct. Anybody who does database modeling or relational modeling, you basically, normally you'd start with a conceptual entity relational model, you'd move to a logical model where you denormalize, and then the physical model where you add your indexes and types. In the graph world, you literally encode directly from the conceptual model, because the links, which are the relations in a conceptual model, are first-class citizens. And that's as techy as I'm going to get today, but hopefully that at least gives you a starting point for thinking where we get for this. So what did I do, and what did we do, I should say? We create a direct model of the network, and that is the digital twin. We track everything that goes through that network. It can be parts, it can be things you're selling, bananas. It can be coffee beans, actually. For some reason, they're very popular. Or it can be data reports, actual data items moving through. And one of the examples I give is more car orientated, but actually the most recent thing we are currently building is actually for data operations very directly, which is why we're in the data ops theater, which is tracking all that stuff. We update the network in real time as it changes. That is what makes it a digital twin as opposed to just a model. And we score and prioritize failures as they happen, and we present them directly to operators. So the scoring is really important. You need to know what is the impact of the problem, not just, and that can be dynamic. That depends on when the problem happens. And so you need to be able to perform that analysis in real time as well. This is not something that you can just put a static, this is how important this is score on the node. You have to work it out from minute to minute. We use exactly the same model for root cause analysis, RCA, risk analysis and forecasting. It's exactly the same model, and because it's a twin, it looks like what the business understands. They're not dealing in data world anymore. The last Microsoft thing, she said something that I kind of disagree with, controversially. She said that we need to educate the business in how to work to be data-driven. I think that's entirely the wrong way around. I think we need to educate us as data professionals on how to bring the data to the business. I think that's way more important. And one of the things is that digital twin allows us to do that and gives us it makes it compelling and understandable. Also, that means they'll be prepared to pay for it, which is always a good thing. So that's the most importantly, make it easy for end users. Okay, This is the if my demo didn't work page where I would point, but actually it should work. Oh, and this is what it really looks like. This is a real network. So this looks, oh, it's pretty and understandable, but if you want to see how gnarly a real network is, this is the downstream effect of a single data transfer. It has over 15,000 separate dependencies throughout the business. We operate on that. I can't show you this demo because unfortunately we haven't anonymized it sufficiently yet, and I don't want you to work out who it is because that would be bad. But nevertheless, that's just to give an idea of the sort of complexity that you're having to deal with. I think they've got around about, they're running just over 1 million separate data nodes, column by column, over 40 or 50 deep. So this is our deep link analytics, which we're very proud of. And they're running data transformations, so they're running anywhere between 100 and 1,000 changes to this network every week. They've got 100 separate data teams constantly changing the network. So that's why they asked us to see if we could help. This is the other thing about, we talked relational. Why can't I just use a relational database? Because your model looks a bit like this. And this is the graph model, which is simplified. You would actually have around about double this number of objects in a relational database. A 36-way join. Try writing that in SQL. Try getting it to run in SQL. Try to do it over a significant amount of data. Our friends JLR did. They tried using BigQuery. They used literally every machine that Google had to try and make it happen, and it would not return an answer. So that's why they're in somewhat desperate. They decided to help. They thought, we'll give these guys a go. We did it in 5 minutes. Okay, let me see. So here's the demo. Right. This is where I find out that actually I've got 2 minutes to do this. Hopefully I've got a little bit more than that. Yay. People seem to like the nighttime mode. Do you like the nighttime dark one? Yeah, okay. I'll stick with that. So this is really just to show, we've talked about the particular, oh, I'm doing good to time. I can slow down a bit. Okay, we have a partner who helped to build this. And what we wanted to a display to show people what you should be showing to your operators. When things go wrong, the last thing they want to see is clutter. They want a very clear and distinct way. The idea here is that, for example, and this would be real time to the database, by the way. This is, somebody rings up, they've got a bad report, there's a car that comes off the line, QA has looked at it and went, wait a minute, all my flushes and gaps are completely out here, what's going on? Or the wheels, we've only got 3 wheels instead of 4 at the end of the line. The first thing that they want to do is to be able to immediately see upstream of that what's going on. And so the first thing you do, if I can make it work, is show me upstream what's going on. And so this is literally what the graph database is doing, is tracing back through the network and step by step to find out what are all the things that are upstream of this. Which sounds pretty easy, but remember, millions of nodes constantly changing. It's a very dynamic situation. Once you realize this, you can start then this data, actually, we can look at this in detail, and we can see that there is an upstream element. And so now we know what probably caused the problem, and immediately we can then click on this, and we can say, okay, who else is it going to affect? If you remember, that was one of the key questions. This one doesn't have too many downstream, but we can see there's another 2 reports or consumers from this process, and so therefore immediately you can understand the impact of this. The way we do this normally is with a dashboard where you actually have these in scored order, where they can see it from the top down with a simple score, which basically multiplies, adds together all of the criticalities of these, and that gives you your total impact, which gives you your total priority. It also tells you who you need to call. And so we've solved an awful lot of problems immediately, and we're proactively giving them the information, which is way better than searching through a bunch of Excel spreadsheets, looking at it, ringing up people and saying, what did you do yesterday that broke this? It takes something that can often take hours down literally in front of their faces. And at 4 o'clock in the morning, believe me, that's what you want. You don't want to be searching for stuff. Okay, so we've got the basic what we need to be able to work out what we can do about this. The next question we talked about was, is that really what caused the problem? The chances are it's actually upstream something that caused this issue, particularly when you're doing data changing. It may be that data's being moved through the various parts, so you've got all these various different pieces here, but actually the problem could be way upstream, and we can see that this is like 20 changes occurred at this particular hub, this data hub. Maybe they updated the schema, maybe this is a change of data source, or they've moved from a legacy system to their data warehouse. The particular application we're looking at is a snowflake transformation, which is why there's an awful lot of changes as they move. And so the idea is, okay, let's have a look at that. And this is where the root cause analysis actually becomes much more dynamic. And normally that's something that takes weeks, is thinking about root cause analysis. But being able to get a sense of what do I focus on and what do I invest in, then having that ability to very quickly move upstream and do pretty much the same, go through the same process of working out, if I was going to fix something at the root cause rather than just a band-aid, which one would I pick? Then let's pick this one, for example. It's exactly the same process. How many things would be affected if this went wrong? That's the first question you want to ask, and that allows you to essentially prioritize your investigation as to whether this is where you want to look. The other dirty secret of root cause analysis is that, and if anybody here is from automotive, I will refer you to Ishikawa diagrams, which are fishbone diagrams. There is never one root cause. There are always at least 8. So I think it's surprising how often think, oh, we'll just find that one root cause, we point at him and say fire him, and that's it, we're all fixed. Whereas in fact there's usually a tension between different things. You know, I changed the report, it's your fault for not dealing with it. And you know, and the guy says, what do you mean I should have dealt with it? It's your fault for not testing it. It's that kind of where you have multiple areas where you could actually deal with it. So we do the priority piece is here at the root cause. We pick this on the upstream, and what we can see is, and that actually downstream of this is a huge number of things are dependent on this. That actually allows us to effectively heat map your network in real time in terms of what are my high risk areas throughout my heat map and throughout my network, and therefore these are the things that I should be concentrating on making as robust as possible. We also give them an API for change management so that they can see column by column, if I change this column, if it went wrong, who would it break? And that allows them to have different layers of change management. If it's something that's not going to hurt anything, then just let the squad bang it through on Jenkins, it'll go in, it's probably okay. If it breaks, we'll fix it at the time. If it's something like this, which is really important, then get the architecture change board out, that's going in there. We need to see a comprehensive test plan, we need to have people on standby for when we make the change in case it breaks it. You know, having that ability to triage also allows you to be efficient and quite lean in terms of your change management capability, and allows them to move fast, which is the great tension. How can I do a digital transformation if literally every column change I do has to go through a change board? It's impossible, you just can't move fast enough. Equally, how dare I make a change when I don't know whether it's going to break the world? And that's what causes the waking up at 4 o'clock in the morning worrying about the phone call. So this actually gives the entire list of dependencies and allows them to be examined. It means that you can do accelerated change board processes, and you can do risk-based approaches as far as the level of ceremony required to make the change management work. So, and this, I think, the last point I had on my original slide was that you want it to be meaningful to the business. This works for operations, because they can see it in front of them, they can recognize it, they can get the information. There's data detail here. It's got an API so that we can put it on standard operational boards. If somebody has a system as well, they don't want another screen. They've already got 20 screens. Can we actually send events and push it through their automation? People can get paged, you know, you can integrate with all that stuff. Because you don't want to replace this. We are not a full enterprise ERP system really what we want to be is to provide that extra bit that's going to make those really comprehensive legacy systems basically have this kind of agile, reactive capability that they don't already have. So that's your operations team. Your change management team can use it, exactly the same picture. Your strategic systems can use it, exactly the same picture. Because they're using the same picture, and this is the contextual idea of a graph as a model of the world, now when they're talking to each other, they actually are agreeing on the same thing, because this is a great problem. Everybody thinks they've agreed, and actually they're agreeing to different things based on different assumptions. This very concrete view of the world, the whole idea of digital twin, I think is incredibly powerful for bringing this to the business. I can now go to the business guy and say, we need to spend 100 grand on fixing this. And they will go, why? And you'll go, because all these guys are going to call you at 3 o'clock in the morning because their tills don't work at night, aren't going to work the next day. So therefore it's probably worth investing in that. And they will go, got it. End of conversation. As opposed to, here's a giant list of data dependencies, we're not sure, but it seems really important and we're a little bit scared. That's not a reason to invest the limited funds that they've got available. So this gives everybody the information so they can do that, which is really the point. I've just had the 5 minutes sign. I do want to give some time for questions. This deck, there's a few other pieces on here with a very small amount of architectural detail and some forward, which talks about just what that looks like. We're on all the clouds, all that type of thing. But I'll take questions if I can. I don't know whether there's a question mic or whether I'll just have to just make the guy run at the back. But if anybody has got any questions, I'd love to take them now. Sir. Sorry, I should have given you some warning.
Can I hold it? All right. So you mentioned the TigerGraph also has analytics capabilities.
That's correct.
So what the experience looks like for the actual the analyst who does analytical queries? What's the querying language as well?
Okay. We have different ways of helping. So one is we have a Python adapter, which means that people who are very much in the data science world and they want to integrate with Jupyter notebooks or things like that, we can do that immediately, and that means at least you know where you're going to bring this data, and that integrates with, that's where the AI integration comes in. For people who want to get into the graph database themselves, we offer a Graph Studio tool, which is a developer tool, which kind of gently brings you into doing this, and there's even a visual querying language which you can use initially to get going. It helps with mapping of data into the graph database. It also then, you can then do code level programming. The language, we have a thing called GSQL, which is our version of the language. We are one of the 3 founders of the GQL standards body, which is basically bringing together NEO, who of course are the grandfathers in this space, but also our Oracle, in the sense that they want it to be a little bit like SQL. And what we're adding in is we want to make sure that we can still do this kind of parallel analytics without breaking the language. And so that should be out in a year or 2. But we're finding that it takes, people can be useful on this in maybe a week. Really not very difficult. GSQL 101, our 101 is maybe 3 hours. And that's because it's not a million miles away from what they're used to with relational databases. It's really just this idea of links, and then you start getting into the idea of, okay, so what extra can I do with that? And really what it is not only you get the data from what you want, you get the data around it. And as soon as people get that bit, they go, oh, okay, so that means I can push more features to my model, or I can start scoring according not only to me, but also my friends. And so it's really quite intuitive once you start on that. The language obviously takes a bit of getting used to, but as I say, it's doable. And I think the point is the value is there. It makes it worth it. You feel like it's actually worth putting in that effort, I think. I hope. Thank you. Any other questions?
No, he doesn't have to move very far for this one. So I've used dashboarding and monitoring applications like App Dynamics. Have you heard of it?
Yes, I know App Dynamics.
That obviously does dynamic discovery, which looks very much like what you're doing here. What's the extra added value that your product has over something like App Dynamics?
Okay, so we are actually downstream of things like App Dynamics. So discovery tools that actually discover the network. What we expect is that is for that to be converted into essentially change events or discovery events. Those discovery events are then passed into our system and we join it together into this graph. So we don't compete with the mature elements in this area. Again, this is part of our main point, which is we need to be incremental rather than replacement for stuff like that, but we don't replace log monitoring. There's others, Datadog, Splunk, and others that have a similar capability in different areas. Really, what we do is tie it all together and then give you that extra information as far as that works. But we can, for App Dynamics, it works on traces is something that it generates, and actually traces are the equivalent of the parts moving through the system, which can be very useful, but we leave the detail on those systems. We use it just to update the model effectively. Now I know officially this is the end, but I'm going to run a couple of minutes over if that's all right.
Last quick one.
Last quick one, okay.
Yeah. So is the criticality is only based on number of links, or there could be other options to like other criteria to weight the criticality?
Yes, it can be totally any criteria across that. In fact, some people use machine learning to decide what those weights and criteria should be, which is kind of a sexy way of looking at it. Okay, thank you guys for being patient, and I'll come and see us at the stand, ask any questions you like, and I'll look forward to speaking to you. Thank you, bye-bye.